Hello students. Now the next factor what we are going to talk about is oxygen, and the first one what I spoke to you all was water, how it gets affected. I told you all questions based on small definitions can come from these, as in what is freeze and thaw weathering, hydrolysis, chemical weathering which is done by solution. So questions based on that also can come. Now we are going to move on to oxygen. Now, oxygen in the air and water reacts with certain elements in the minerals inside the rock. We all know that there are certain minerals inside the rock. Oxygen in the air reacts with these elements. In this process, the minerals, the minerals in the rock react with the oxygen in the air or water. Whether it's air or water, it reacts with both. Metals in particular, iron and aluminium, commonly oxidize. Oxidize basically combine chemically with oxygen. When I say oxidize, commonly oxidize, basically it means combine chemically with oxygen, forming iron or aluminium oxides. Compared to the original rock, these oxides are less hard, larger in volume. Now, this is the characteristics when they are compared to the original rocks. They are less hard, larger in volume, and have a distinct color, a very different, unique color. If you look at figure 2.3, generally the iron oxides are red in color and aluminium oxides are yellow. Now, I'll just show you all this figure 2.3. I think it's there. Figure 2.3, the iron oxides, they are red in color and aluminum oxides are yellow. When oxidation happens on steel or iron objects, we call it rust. Now, what is rusting? Oxidation in figure 2.3. What is rust? Basically, there's presence of moisture. When rusting takes place, there's presence of moisture. You will always see a brown flaking coating of iron oxide which is formed. There is a coating which is brownish, yellowish, reddish coating which is formed due to iron oxide. The next thing what we are going to see is carbon dioxide. Now, carbon dioxide, this process involves reaction of carbon dioxide with the minerals. Over here, what happens? Previously, oxygen was reacting with water and certain elements in the minerals inside the rock. Over here now carbon dioxide is reacting with the minerals in the soil. The decomposition of dead matter in the soil produces carbon dioxide. Decomposition, I repeat, what is decomposition? It's basically state or call it process of rotting. So the decomposition of this dead matter in the soil produces carbon dioxide. This carbon dioxide and the carbon dioxide in the air, these both, they react with what? The minerals which are already present. As and how you all will go through every factor. Minerals are always present in rocks. So there is a chemical reaction happening with these rocks which already have minerals in them. Minerals such as feldspar and carbonates decompose again rot when this happens. So minerals such as feldspar and carbonates decompose when this happens. This is particularly true for sedimentary rocks such as limestone. Now sedimentary rocks, as I said, stratified rocks, layered rocks, it is true in that case. So over here what happens is decomposition happens in sedimentary rocks and in particular limestone. In humid climates, water adds to the weathering process. Now, water adds to this weathering process. In arid climates, what happens basically? Arid climates, the absence of water in the region leads carbonate rocks to form cliffs. What is arid climates over here? Arid climates which are dry, extremely dry or without moisture. The absence of water in the air region leads to carbonate rocks to form cliffs. Cliffs, what are cliffs basically? What do you mean by cliffs? High area of land next to the sea with a steep side. which has a very steep side. They are resistant, that are resistant. So often carbonation that are resistant. Often carbonation and solution occur simultaneously. During carbonation, the calcium and carbonate in limestone depth detach from each other. They basically disengage. Detach means isolate or disengage from each other, thereby decomposing the limestone. Now, this part of weathering, basically the factors or how the chemical part, there's a lot of science in it. So there are reasons, there are scientific reasons why certain things are happening in a particular way. The third point is salt. Though salt is a chemical compound, it can also dry out physical weathering. The salts of calcium, sodium, magnesium, potassium, etc., present in the rocks have a tendency to expand, to become more, to expand due to their thermal properties, due to the thermal properties. What does thermal properties over here mean? Actually, thermal properties basically uh, they explain the response of a material to the application of heat. I repeat, thermal properties means they explain the response of a material to the application of heat. So, they expand due to their thermal properties. This leads to crystallization of salts and individual grains split from the main rock. Over here, there are small granular uh, pieces which split from the main rock and they fall off at the end. Such a type of weathering is especially dominant. Now, this kind of weathering is dominant in particular areas. Such a type of weathering is especially dominant in areas with alternative dry and wet periods and in coastal areas, in the coastal belt, if you see. So, these are prominent in wet, dry periods and in coastal areas. It leads to formation of honeycomb structures. See figure 2.4. Now, if you look at this figure, example Hareshwar in Raigad district. These structures are examples of the combined effect of physical and chemical weathering by water. Now, there's a question over here. They are saying in which regions will freeze-thaw weathering not be affected? You have to find the answer. I can give you a small explanation to it. Now, freeze-thaw weathering is not effective where basically if you think of in cold polar regions, the soil covers and rocks are very little on the polar areas. There is snow everywhere. So this in this region, freeze and thaw weathering will not be effective. The next point we are going to talk about is after salt is heat. In areas where water availability is rare, so you hardly find it, weathering process is mainly induced. Induced over here means to bring about by temperature. Hot desert are the areas of high diurnal range of temperatures. What do you mean by diurnal? Basically difference between the day and night temperature or the minimum and maximum temperatures. That is the diurnal range of temperatures. As the temperature increases with the rising sun, the rock gets heated. The minerals in the rock, when the rock gets heated, when the temperature increases, the rock gets heated. What happens next? The minerals in these rocks react differently to the increased temperature. Therefore, the rocks as a whole does not expand, but different minerals expand. The minerals within the rock expand separately. This leads to the development of stresses within the rock. There are different kinds of stresses, cracks or fissures or cuts you can form. There's tension. So this leads to the development of stresses within the rocks. The molecular stress or this molecular stress becomes the prime factor. Prime factor meaning main factor in disintegration. Disintegration means and basically breaking down, disintegration of the rock. This differential thermal expansion, growing and contraction, coming to closer, contributes to granular means grains, disintegration, granular disintegration. Heat, it means the breaking free of individual mineral grains from a rock. So when heat, the temperature increases and there's tremendous heat, what happens is the grains, mineral grains break free individually from a rock. Look at this picture. Next, you will understand. If you look at this granular weathering, how does granular weathering take place? In a similar process, the rocks break away due to heat. Now, in the same way, the rocks break away due to heat. This is called shattering. Now, students, under each factor, there are some definitions which can come for the exams and which can come as name the following or match the following for you all. You'll have to understand what does granular weathering mean, what processes take place under them, how does heat act as a factor affecting weathering, how does carbon dioxide affect weathering, how does water, salt affect weathering. I will repeat it at the course at the end of the lecture. I will repeat it again so that there is clarity in what we are doing. This, in a similar process, the rocks break away due to heat. This is called shattering in hot deserts. Now over here they are talking about in hot deserts, what happens when the rocks break away due to heat. This shattering produces a sound similar to firing of pistols. So the shattering sounds is related to the firing of pistols. This breaking of the rock is very intense. It is very intense. Intense meaning strong, the severity. It's very intense. And hence such a sound is produced. And hence such a sound is produced. You can see figure 2.6. So shattering. Now, in rocks such as granite, which have joints, heat can cause weathering. See, there are different rocks reacting differently under heat, water, carbon dioxide, or coming in contact with oxygen. So the reactions are very different of different types of rocks. In rocks such as granite, which have joints, heat can cause weathering by breaking the rocks along the joints into blocks. This type of weathering is called block disintegration. It is particularly effective in areas where diurnal range of temperature is high, meaning maximum and minimum temperature, the difference between them is high. The repeated expansion, the repetition of expansion and contraction of minerals in the rocks produces stress along the joints. The joints then widen, deepen, and finally break down the rock block by rock. When the rocks break down block by block, it is block disintegration, breaking down of rocks in blocks. Block disintegration. This is figure 2.7. Though heat may not directly cause chemical weathering, it certainly speeds up chemical weathering. See, heat may not be directly responsible for chemical weathering, but it definitely speeds up the process of chemical weathering. It can become more effective with increase in heat. The third point is pressure. Now pressure, because of the overlying rocks, the rocks beneath the surface experience a lot of pressure because the overlying rocks means on top of the other. So the rocks beneath which are there, the surface, experience a lot of pressure. There's natural pressure. When the rocks underlying rocks get exposed to the surface, when they are exposed to the surface, they are now subjected to low pressure than before, because the overlying rocks have been removed. This is how the change takes place, and this is how the process moves on. As a result of the pressure differences at depth, that is high, and surface low, the outer part, a few centimeters to meters of the rock mass, expands outward. This expansion causes the outer layer to separate from the lower layer. Over here, let's understand this again. What is happening? The rocks which are one on top of the other, overlying rocks, and the rocks beneath the surface, underlying rocks, experience a lot of pressure. So when the underlying rocks which are lying underneath get exposed to the surface, are subjected to low pressure than before, because why? The overlying rocks have been removed. When the overlying rocks have been removed, the direct pressure falls upon the underlying rocks. Then the pressure is more. Or else when the overlying rocks are there, the underlying rocks feel less pressure. As a result of the pressure differences at depth, high and surface low, the lower part, a few centimeters to meters of the rock mass, expands outward. This expansion causes the outer layer to separate from the lower layer. Now, due to this expansion is happening and they separate out, the outer layer separates from the lower layer due to pressure. This type of weathering is called dislodgement. So, weathering which is due to pressure is called dislodgement. Why does this happen? This happens due to pressure release or unloading. Basically, it's pressure release or unloading. It is common in igneous rocks, the primary or the parent rock, particularly granite, where rock forming material is homogeneous. Homogeneous means same. The successive removal. The successive removal means following one after the other. Removal of these outer layers of the rocks is called exfoliation. So the removal of the outer layers of the rocks is called exfoliation. Now there's so many terminologies which I'll cut them short, and we are going to discuss about those and what all we can learn or what can come from the exam point of view, which is very important to know as definitions or to know as MCQs or to know them as objectives or long questions also. In areas where coarse-grained igneous rocks like granite are found, the cracks in the outer surface form a dome shaped. It is dome-like. In Deccan Plateau areas such as Karnataka, Andhra Pradesh, Telangana, and Odisha, one comes across such domes. So these are these dome-shaped rocks which are formed, like example granite they are saying. In which places? Deccan Plateau areas such as Karnataka, Andhra Pradesh, Telangana, and Odisha. So one comes across such domes. Now students, here we have finished with what are the factors which affect weathering. A small summary of what we did now. We will do it again. The first, see, there is physical and chemical weathering happening. And basically, what is weathering? It is the physical or chemical breakdown due to weather conditions. Now, it can occur due to water, temperature, and the reaction of rocks to these processes. So, what is this? Basically, when there is no motion of rocks or materials in weathering, it is called in situ process. In water, I have told you many times that there's a process called hydrolysis where the water molecules react with minerals present in the rocks, which is called hydrolysis. Then the second thing what we learned about when there is chemical weathering happening by solution. Over here what happens when some minerals in the rock react with the water in the rock or moisture in the air and get dissolved. This process is called solution. So this is another short definition what you all can learn and which is very important from the exam point of view. How does oxygen help, or how does oxygen play as an important factor in affecting weathering? It is basically oxygen is already present in the air, so then water also reacts with certain elements in the minerals inside the rock. Over here, metals, particularly like iron, commonly oxidized, forming iron or aluminum oxides. So when oxidation happens on steel or iron objects, we call it rust. I told you oxidize, basically what does it mean? It combines chemically with oxygen. And rusting is what? When there's lots of moisture, lots of presence of moisture, that flaking brownish yellowish thing coating which is formed due to the iron oxide. That is when rusting takes place. Second was carbon dioxide. We spoke about carbon dioxide. Now, how does carbon dioxide play a role? This process involves reaction of carbon dioxide with minerals. And over here, the decomposition of dead matter. Decomposition is a process of rotting of dead matter in the soil produces carbon dioxide. Minerals such as feldspar, carbonates decompose when this happens. In humid climates, water adds to the weathering process, but in arid climates, that is the extreme dry or without moisture, arid climates, the absence of water in the region leads carbonate rocks to form cliffs. Cliffs, as I said, they are high area of lands next to sea with a steep side and that are resistant. During carbonation, the calcium and carbonates in limestone move away from each other and therefore they decompose the limestone. Salts. What about salts? Salt is a chemical compound, we know. It can also carry out physical weathering. The salts of calcium, sodium and magnesium present in the rocks have a tendency to expand to their thermal properties. When we talk about thermal properties, what does thermal properties mean? It explains, basically when we talk about how the proper thermal properties, they explain the response of a material to the application of heat. They've given us an example. It basically forms honeycomb structures. And this example of salt affecting as a weathering process is Hareshwar in Raigad district. Then I explained you all which region will freeze thaw, weathering will not be effective. Cold polar regions, I want you all to get into more details of which region can really uh, does not get affected by freeze thaw weathering. Now heat. Over here, heat also they've given us a lot of information about heat is disintegration and how disintegration takes place. In this, when water is rarely available, it is mainly induced by temperature. So when water is rare, the second thing what plays an important role is temperature. So hot deserts are the areas of high diurnal range of temperatures. As the temperature increases with the rising sun, the rocks get heated. Temperature increases, the rocks also get heated more. So the rocks react differently to the increased temperature. Now the rock as a whole does not expand, but the minerals inside them expand due to heat. What happens with this? There are stresses within the rocks. So the molecular stresses become the main factor of disintegration, breaking down of these rocks. This differential thermal expansion and contraction, there is contraction and expansion happening, which contributes to granular disintegration. Now, what is granular disintegration? Means that the rocks, basically the mineral grains break free individually from the rocks. So that I showed you on figure 2.5. They have given you a picture of granular weathering. Now in the similar process, they are saying the rocks break away due to heat. This is called shattering. When the rocks break away, this is another terminology which can be asked in the exams. What is shattering or block integration? So the rocks break away due to heat. This is called shattering. In hot deserts, this produces a similar sound to as firing of pistols, and it is very intense. Intense meaning strong. In rocks such as granites, which have joints, heat can cause weathering by breaking the rocks along the joints into the blocks. When the joints into the blocks are broken down, it is called block integrating in disintegration. It is particularly effective in areas where there is diurnal range of temperature. Again, diurnal change of temperature means minimum difference between minimum and maximum temperatures, or day and night difference in temperatures. Now over here also the repeated expansion, and see, when there is expansion and contraction happening in the rock, students, what happens is the mineral produces stress along the joints. So the joints, what happens, they widen, they become deepen, and they finally break down the rock block by block. So this, now they have already said that heat may not be directly the cause of chemical weathering, but it speeds up chemical weathering. Pressure, the last factor which affects weathering is pressure. Over here they've spoken about what is exfoliation and dislodgement. Now when the expansion causes the outer layer to separate from the lower layer of weathering, this type of weathering is called dislodgement. Why does this happen? Because of the pressure release or unloading. Same way, and this is common in igneous rock, that is the parent rock. Now suppose they've given an example of granite where rock forming material is homogeneous. So when the removal of these outer layers is successively happening, it is called exfoliation basically. So there can be questions based on it, long questions based on it, which can be asked as define hydrolysis, the two ways uh, how water breaks down. Chemical weathering happens through water, that is chemical weather by solution, chemical weather by hydrolysis. Then oxidation, how does carbon dioxide play as an important play an important role in the factors affecting weathering. What is disintegration, what is dislodgement, what is exfoliation. All of these questions can come based on these types of weathering. So the next topic what we are going to talk about, if you see page number 19, use of brain power, whatever has been highlighted is being deleted, as you already know. So we don't have use your brain power. Can animals and plants also influence weathering? Will that be physical or chemical weathering? Which type of weathering does stone quarrying? This is not there. Think about it is also deleted from your syllabus, and do you know also is deleted from your syllabus. So the next class what we are going to talk about is different types of weathering. Here what they are covering is biological weathering and anthropogenic weathering. I will give you all some more details and some more different types of weathering I will be talking about. Mechanical physical weathering, which is one topic. The other topic I'll be talking about chemical weathering again, and what are the effects of weathering also I will be talking about.